Hello, everybody. I am Bob Plankers, and I am joined by a whole bunch of other people here to do vSphere Live. We do this on a monthly basis, get together and talk about infrastructure things. And my video is freezing for some reason, so you'll just have to, and we've seen in other cases where, technical glitches don't get us down at all, and so we power through them. All is good. We're infrastructure people. We like this stuff. We like the challenge. So anyhow, I will, let's get on with it. We're going to talk about what's new in vSphere 7 Update 3, vSAN 7 Update 3, and the last patch, the patch that came out last week that adds a bunch of AI and ML support as well. So for that, we've got Pete. Do you want to introduce yourself?
Yeah, thanks, Bob, for having me. My name is Pete Keeler. I'm a vSAN technical marketing group here at VMware, focused, just as the name implies, on vSAN, all things vSAN, it seems like. So, that's mostly what I focus on. So
cool. Who are you, Justin? What are you doing here?
I think I know what I'm here for, but I'm Justin Murray. I'm in technical marketing also. I'm in Ken's team, having a fantastic time working on AI and machine learning and GPUs and all that stuff. Such an interesting time for VMware with that.
Excellent. And who the heck are you, Ken? My partner in crime on these things.
Longtime fan, first time caller. Yeah. Right. No, I manage our technical marketing team for core vSphere, including a lot of these pieces that you talked about. vSphere itself, as well as some of the adjunct things and things we're developing, like Tanzu for Kubernetes orchestration and the AI/ML pieces that Justin focuses on. So that's
very cool. So one of the things about this stream, if you're watching, and thank you very much, we appreciate you being out there. We know there's quite a number of people out there watching. Hey, if you've got questions, comments, thoughts, put them out in the chat, and we will answer them live. With my eyes closed, apparently. There we go. That's never ceases to amaze me, the facial expressions. Ken was noting them earlier. Whenever it freezes, it's always the greatest time. But put your comments out in the chat itself, and we will answer them as best as we can and put them up on the screen when you have them. So we appreciate that. But let's get us started here. Pete, I think we should start with vSAN. vSAN's really cool. I've been a big fan of vSAN for a while, rhyming or not. And what's new in 7 Update 3? We get a new storage array every time we patch, right? So what's new in this version of the storage array?
Yeah, that's right. So Bob, one of the things that we really seem to focus on release after release, it's about making things easier, as well as introducing new functionality into the platform itself. And vSAN 7 Update 3, it follows that same line. And so when we look at the first thing about making things easier, that for this release can be summarized really in a few specific features. One of them that I really like is this idea of a health check correlation capability, or a relationship mapping of health checks. So now, vSAN offers dozens and dozens of health checks. I think it's nearly 100 at this point. And that's great and everything. It's a lot of these guardrails to help ensure that you're configuring things correctly. But when there's an issue, we know that just the nature of any sort of alerting, one alert may be triggered by another alert, but sure, you never know which one is, the cause or the symptom. So the health check correlation helps you understand what is the symptom and the cause, and it sort of maps that out for you right within the UI. So this is just a fantastic improvement for that, for the day-to-day operations. When you walk in, you see those triggered health checks, and you go, which one should I look at first?
Yeah.
And sadly, historically, we've always done, well, which one looks the easiest? And
that's usually the wrong one to pick.
And it's likely the wrong one. So that's one of the aspects that we focused on vSAN 7 Update 3. Another one that we focused on from an operations standpoint was, occasionally, and we've certainly heard this from our customers, is that when they have a need to do a full cluster shutdown, let's say they're moving servers from one rack over to another, so forth.
Or turning the power off or something. I
Exactly.
used to do that once in a while. That was always fun. How do I do it?
Yep.
Did you fix that? You've got a solution for that now?
We do. So now, we knew that like in a traditional 3-tier architecture, it was something that it was fairly straightforward in many respects. But when you have a distributed storage system, the data is kind of sprinkled all over the place. The VMs are sort of sprinkled all over the place. So we built in this new workflow that just makes it really easy for the customer to walk through this process of doing a full cluster shutdown. And it's going to do all the health checks, and then it's going to orchestrate that process itself, shutting off HA and bringing down some system related VMs. Now, the responsibility of the actual user VMs, that's still on the user, as it should be. But then once that powers down, then this very same workflow is going to offer that guidance on the power up as well. So that's, yet another kind of aspect on that operations side that makes things really easy.
That's really cool. No, I like that. And I like that we're thinking about, because it's friction. It's not, it's not a make or break sort of thing, but it's the sort of thing that makes life easier for the vSphere admins. I know you were a vSphere admin, as was I back in the day, and I often think about all of the pain and suffering that we had to go through with older versions of the product and how much better it's gotten, and even just the fight. I was talking to somebody the other day about the fight with the HTML5 client. That everybody hated it when it came out, and because everything moved. But then you realize that some UI person, UX person actually figured out where to put all that stuff, and why it should be there, not just slapped in there by an engineer, but where does it really belong if you're thinking about humans. And I really like that we think about the humans.
I've sat in on a number of those UI sessions with people, and we have people with doctorates in user interfaces that will sit down and go through with you and say, all right, please try to find this feature. And they watch and see how many clicks it takes and how long you have to move the mouse. And there's so much that goes into that in terms of identifying how they can improve that UI. It just takes time. That's all it is.
Yeah.
And I think
I did that at a VMworld once. A friend of mine who was in marketing had me sit down with a PC and their software and a bunch of engineers just watching me, and they're like, install it. And I'm like, do I get any manuals or anything? They're like, no. And you can't ask anybody or anything. And so I was proving a
think it should be.
But yeah,
Well,
hey, we've got some, go ahead.
And one of the things that we recognize here was something like a full cluster shutdown. It wasn't necessarily a very difficult thing to do, but you had to follow a series of steps. And anytime that you're following a manual set of steps, that's prone to error. And so this really just ensures that predictable result, which is really what you're hoping for in the first place.
Yeah. The journey is not the destination. The destination is the destination. You want it shut down so that you don't lose data in that, or you want to turn it back on. And so, yeah. Hey, we've got a question out here from Salam. Any new here? Let's see if I can promote it hey, there we go. Any new storage profiles for 2-node vSAN stuff? You do have some announcements about 2-node vSAN, don't you?
We certainly do. Yeah, that's that is.
I swear, I did not. It's a perfect question. Yeah, he's not a ringer.
It's very timely in the sense that with vSAN 7 Update 3, we offer something known as nested fault domains, and this is what it basically does: is that it offers a secondary level of resilience in a 2-node cluster. So generally, if you think about a 2-node cluster, you have, just as the name implies, 2 hosts. You have the data that's mirrored to both hosts. Now, what this feature allows you to do is to be able to create a secondary level of resilience so that you can protect against a full host failure plus a disk group failure that lives within the one remaining host. So now you're creating this environment that's extremely robust, But yet you can do this in a very granular way because you're assigning it based off of storage policies. And so it mimics the secondary level of resilience that we have within a vSAN stretch cluster, but now it's just applied in a two-node arrangement.
And
So
Pete, you
that
got
you-
options in terms of the types of policies for that secondary level of protection. Is it always going to be mirror? Can you do RAID levels 5 and 6 and things like that, depending on how many disks and disk groups you have?
Yeah, so with the secondary level of resilience, you're going to be highly dependent on the number of disk groups that you have in each host. Now, the minimum needed for that secondary level of resilience is 3. That's going to offer a mirroring capability at that secondary level of resilience. But if you have 4 disk groups, then that offers the opportunity for you to assign that a RAID 5 erasure code. So now you can have this really space efficient mechanism for that secondary level of resilience. You can't do RAID 6 because that would require 6 disk groups, and we have a maximum of 5 that can be supported in each host.
Makes sense.
So I'm just thinking about that because I had a couple of 2-node clusters back in the day, and that would have been interesting. So just do, what did you say? 4 disk groups on 2 hosts? 4 disk groups each host, 2 times 2 hosts plus a witness.
Yeah, the now of course 3 disk groups will be that minimum point of entry. You could do that.
Sure, but you get full mirroring then, right?
Yes,
you don't get the space efficiency.
Yeah. So it offers just a lot of ability to create this very small cluster, but it can run extremely important workloads. Because we always think small cluster, somebody may think, well, not very important workloads. Well, if it's on the edge, it may be critical. And that sort of reflects that.
Yeah, that was my experience. The stuff way out at the edge is real-time stuff. It's really important to something that it has to be that close to, and so. Here, we've got another question. It's a little here. I'm actually very curious what happens when I promote it into the stream here because it's huge. There we go. We lose Ken and Justin.
Oh,
yeah.
First question ever.
So basically, do we still need to use the same controller, or can we use the same controller for vSAN and non-vSAN workloads? It wasn't recommended in the past. Has that changed?
The recommendation has not changed. And in fact, this is actually becoming a little bit less of an issue as time moves forward because NVMe-based storage is becoming so easily accessible. The price point is fantastic. And the thing about NVMe-based storage devices is that it has its own built-in storage controller. So it just makes that issue a non-issue, but the basic recommendation has remained the same.
Keep them separate.
So,
keep them separated. What is that? Which song is that? That's is it the
Come Out and Play? Come Out and Play.
Offspring or something like that.
The Offspring, Come Out and Play. That's the one.
Offspring. Nice. Cool. Well, and speaking, I mentioned witnesses. The vSphere Lifecycle Manager can now manage a standalone vSAN witness, right?
Yeah, and
or updated at least.
So once again, just focuses on just making this thing easy because whether you have a 2-node arrangement or a stretch cluster, you're always going to have this witness host appliance somewhere, but yet it has this relationship with the cluster. But the one unique characteristic about this witness host appliance is that it was never a part of the cluster, so that when you went to update it, you would update the cluster. That's great, but then shoot, I forgot about the witness host appliance
over here.
And then wait, which order should I do this in, and all of that. So now with vSAN 7 Update 3, courtesy of the vSphere Lifecycle Manager, we are able to make that all one cohesive update. Makes it nice and easy for these environments that are using either the 2-node arrangements or vSAN stretch cluster. And the only time that it actually that it won't perform the update is that if you have a 2-node arrangement, multiple 2-node arrangements where you are sharing the same witness host appliance, then you'll go through the traditional updates. But in every other situation now it's fully managed by VLCM.
LCM is cool. It's kind of eating the world as far as just taking over patching. As a security guy, patching is really important, and remembering to patch, reducing friction, all that sort of stuff is cool. So cool. Do we have so if that's vSAN, that's vSAN 7 update 3. That's wonderful. You get that automatically when you update your vSphere instance. So that's really cool. I think there's a disk, if I remember correctly from my lab, there's a disk format upgrade that you have to do as part of it, which happens from but it's automatic.
Yeah, I think what we're up to almost what I believe it's like version 15 of it, but it's these are generally and historically, at least within the last several versions, just been a lightweight metadata based update. And once again, we kind of provide that health check for the users in that event as well.
Very cool. No, I like that. Cool. Ken, Justin, any other thoughts for Pete here?
Oh, I just went through that very thing, shutting down one cluster, moving over to another, and having vSAN take control, and it was a pleasant experience. Nicely done. It's definitely made things simpler and easier.
Words rarely spoken. Shutting down my cluster was a pleasant experience. So I think
normally it's done for me, like I enter a dark room that my cluster is inhabiting, yes. Whoops. But
yeah.
Hey, we've got another question popping up here. Sorry. Any updates around vSAN storage snapshots? I don't know that there were. Pete?
No. So we're still using vSAN sparse as the fundamental mechanism for our snapshots, but no changes. Now that doesn't necessarily reflect, maybe some changes on the VMFS side. So I won't necessarily speak to the updates there, but yeah, on the vSAN side, it remains the same at this time.
Oh, Salam's got another question. Does it still require vSphere Enterprise Plus for vSAN stretch clusters with vSAN encryption?
Oh, now you're going to quiz me on my memorization skills.
Here's the deal, Salam. We're not really licensing experts, I think the answer is yes. It's still, I don't think anything changed in that regard.
Yeah.
I will say that native key provider, which can be used for vSAN encryption, is licensed across all vSphere levels, so it doesn't require Enterprise Plus. vSphere vSAN encryption is a separate license. It's part of the advanced license, if I remember correctly. Not sure. But vSphere and vSAN licensing are different. So the key provider you might need. Yeah, my video is freezing. I'm driving.
Yeah.
Here. What do you think, Pete?
Yeah. So and I think that's a great distinction in recognizing sort of the requirements between vSphere and vSAN. First, we have licensing that is required to support a certain topology, that being vSAN stretch clustering, and then licensing that is required to support the encryption services, whether that be data at rest or data in transit encryption. And I believe on those they may be enterprise, but I could be wrong on that.
Enterprise. So, I just looked it up.
Okay.
I took the second here.
Oh, did you?
Yes.
Okay, good.
Thank you, Ken. You bailed me out once again.
Ken's like our built-in researcher here. So.
Yeah, that's licensed research. Yes, my childhood dream come true.
Yeah. Yay. Let's see.
So actually, while we're talking about that, let's take a brief moment there, because I think a lot of people aren't necessarily familiar with the difference between data in transit and data at rest encryption, and the fact that we have two different options on that for both vSphere and for vSAN, obviously too. So when would I choose one versus the other?
Mm-hmm. So vSAN data at rest encryption is just as the name implies. It is encrypting the data as it lands on the storage devices, whether it's the write buffer tier or the actual capacity tier itself. It is intended to secure that data as it resides on the storage devices. It doesn't use any self-encrypting drives or anything like that. It's all software based. But that is for the data as it rests. When the data is being transmitted from point A to point B, from one host over to another host, that data in transit or in flight historically has been in the clear or unencrypted. So in recent releases, we introduced the vSAN data in transit encryption, and that's going to offer you the ability to encrypt that data as it is transmitted in the vSAN traffic, as it is transmitted in between the respective hosts. They can be used independently, or they can be used together to create that fully end-to-end arrangement. One little fun fact about that data in transit encryption capability is that it does all of the key management on its own. You don't need to, set up a KMS or any sort of a key provider that's going to be managing those keys. It's going to be doing that transparently for each and every host that lives within that vSAN cluster.
That's the same as vMotion encryption, which is the data in transit encryption for vMotion. When you set it up, this is a common question we get, do I need to set up a key provider or encryption for any of that stuff? And the answer is no. It's just like, it's basically like SSL. It's not SSL. It's a little different, but it's the same relative mechanism where it's interchanging a key, a temporary key. Those temporary keys, the technical term for them is actually a nonce, N-O-N-C-E. And it exchanges that as the temporary key. That looks even better. I hate my video. I'll just leave it off for now. It exchanges a key, and then it uses that to transmit in encrypted thing. There's a key exchange there. So if you ever look at TLS is really interesting because web browsers and all that stuff, that the public key encryption is actually really costly in terms of CPU. Symmetric encryption is not, and so that TLS is actually a key exchange of a symmetric. The public key stuff is only used to exchange a symmetric key, and then the rest of the session uses that symmetric key, and that's the same for both vSAN and vMotion as well. They just do it. They don't. Like I said, it's not TLS, but it's the same basic mechanism.
And the symmetric key is the same on both sides. Sender and receiver have the same key, but it's encrypted using the PKI stuff, I guess.
Yeah. The whole trick, though, is how do I give somebody that I don't know the secret that I want them to know? Right. And I'm saying constantly. How do you exchange that information? And that's where the Diffie-Hellman and the RSA research and all that stuff really was revolutionary. The ability to exchange a secret when you don't necessarily know the other person. So,
right.
Hey, there's some other questions out here. Let's see.
Good.
Yeah, no, lots of interest in vSAN. That's cool. We're gonna need. We'll get to AI and ML here in a second. Because I'm very excited to talk about that as well. We have 2 disk groups on each host. This is another big one. I like it. Sorry, Ken and Justin.
That's okay.
We have 2 disk groups on each host. A new version of vSAN, when we can change one stripe from 1 to 2, it'll be put each part of a component on separate disk on each host. Can we stay in this mode, or can we use more or better from cache tier or write buffer? Is it always better to create a policy with 2 stripes?
Yeah.
Pete, what are your thoughts on this one?
All right. So, I think the person who wrote the question did observe one interesting characteristic, or I'm suspecting they did in previous versions of vSAN. So what happens when we create a storage policy where we are using the stripe width functionality is that we break up the chunks of data and spread them out across more storage devices so that you can theoretically get more performance if the performance is being constrained by those storage devices. And historically, what we had done in the past is that if a customer set a stripe width from 1 to 2, it would break up that chunk of data into multiple components and would place it on the same disk group if there were more than one storage device within the disk group. In recent editions of vSAN, I believe it was changed in vSAN 7 update 1, I think maybe update 1. We changed the philosophy that we use on that striping to where that splitting of the components one would land on one disk group while the other would land on the other disk group. That increases the number of threads that can be used for committing those IOs, and fundamentally just improves the effective performance. Now, this is just all built in to vSAN. It's not something that the user is going to, have to make a decision on or anything like that. But the behavior has changed. My recommendation on Stripe with settings as a rule is start with just not setting the rule at all in the first place, which just starts out simple. It's the easiest for vSAN to place the data that way. But then if you suspect that you have some performance problems, you can up that just incrementally, but then observe the results. Don't start out with, setting that thing up to the maximum, thinking that that's going to necessarily improve things.
I don't like your approach. Just make changes, Pete. Just make changes. Just without
observation.
YOLO, man. We know we don't have time in life. Life is short. I'm sorry, Ken. You were going to say something.
Well,
I'm joking.
You just reminded me of that saying that everyone has a test environment. Some people are lucky if it's also not their production, right?
Yeah, that's exactly right.
Yeah, with modern media, the need for Stripe width kind of goes down fairly dramatically. I mean, striping across a whole bunch of Optane, I'm not sure you're going to see a lot more.
Every time you stripe, you expose yourself to a failure there too. I actually had a system built by a vendor who shall not be named that actually striped whole disk arrays together. And that's always interesting choices when building a system, because how do you maintain one disk array without taking them all down simultaneously? And that configuration didn't live real long. Let's just put it.
And I too was very familiar with that very same arrangement. And yes, you instantly created, let's say, 96 points of failure for
when you could have two.
Thing.
Yeah. Thanks, guys. So, very helpful. Please stop helping me. But there's a comment. I'm still waiting for the VTA cluster to support vSAN encryption. I can speak to this. VTA is vSphere Trust Authority. It's got a great name. I came up with it. The naming is so hard. I'm always surprised anybody listens to me. And but VTA, vSphere Trust Authority, offloads attestation and cluster security and all of that stuff to a separate cluster that does it for a lot of hosts. And you can secure that separate cluster differently. And it's a really interesting technology. And it came out with vSphere 7. People are starting to finally notice it, and I like it, because it requires that extra cluster, so you kind of have to build it in. But it takes over key management. And one of the things about key management, and Pete, you alluded to this, talking about key management, vSAN manages its own keys, or manages its own relationship to the key provider. And so if you use VM encryption, so you can do vSAN encryption at the disk group level, the data store level. You can do VM encryption at the VM level if you want. And you need to do VM encryption, or at least a little bit of VM encryption, if you want to use like a virtual TPM. VTPMs work great with Windows 11, for example, but you need to encrypt a few files on disk, and like the NVRAM file, and so that the secrets that are stored in the TPM are secure. And so those get keys from the key provider, native key provider, or traditional KMS system, whatever you've got. But how does vSAN do that? So the key provider is managed through vCenter Server. vCenter Server can be stored inside the cluster it manages. That's a very popular way of deploying it. In fact, even products like VMware Cloud Foundation do it that way. Other things, a lot of the cloud offerings. And so what happens if the cluster is off, and the thing that all your data is encrypted, and the thing that can get you the key for the encryption is actually on the thing that's encrypted? That's the chicken and egg sort of problem there. And so vSAN actually has to talk to the key providers directly. It knows how to talk to a traditional KMS directly. And so when you start a cluster that's got vSAN encryption on it, it'll go out to the key provider and ask it for the keys, and that's normal. VTA and even native key provider, we've made it work with native key provider as well. It stores the key on the host. That's the way around it, but we don't know how to do that yet. We don't know what the right way is to do that with VTA, because it's sort of, some of the choices you can make sort of violate the whole principle of VTA, that you've got the centralized key management somewhere else, and that if you don't pass the tests, you don't get access to the encrypted data, that sort of thing. And so that's why it's not there yet. We're thinking about it, and I will mention it to our product managers who I'm talking to later today. So no, that's a good comment. Let's do one more vSAN thing, and then let's talk about, well, we've got two. Can you talk a little bit about the new features of vSAN when it comes to Tanzu?
Yeah, so we do have a few new features in vSAN 7 Update 3 that focus on, or that are related to Tanzu. One is that we are now supporting read-write many volumes for vSphere with Tanzu. Now, in previous editions, we were only supporting read-write once, which is essentially a block-based interface as it stands today. And so what this is really offering now, when you have read-write many volumes, or essentially an NFS-based access point, now you can have these pods that are spun up and spawned to multiple instances that can be using the very same persistent volume for those multiple pods versus independent persistent volumes as those things span out. So it just offers a lot more flexibility, and I think this had been a request by many in that where that was very important for them, and so that has been introduced in vSAN 7 Update 3. And then many of the other improvements, sort of in that cloud native space, were not necessarily related to Tanzu, but more focused on just running the upstream version of Kubernetes on vSphere. Those are focused on the ability to support a stretch cluster arrangement for persistent volumes that are being used in vanilla Kubernetes, and the support of topology zones, which is that's a construct of Kubernetes, so that you can have applications that span multiple vSAN clusters, but when those pods are instantiated out even further, it knows to put the right persistent volume in the right cluster for where that instance is actually running. So that's basically, in a nutshell, what has been introduced in vSAN 7 Update 3 for the on the cloud native space.
I think it's interesting that a lot of people have assumed, with the incipient application development shifting over towards containers, that we'd see microservices and everything is going to be ephemeral, and you just like spin them up on demand and they go away. No, that's not the case. Like 70% of new applications in containers still require storage. Like they still need that level of protection and back-end resilience that vSAN can provide. So it's cool to see some changes coming on that front. So we have one more question here about vSAN that I'm going to impress upon Peter.
We've got a couple. I lied, actually. Here, can we do this other one here? Is 7 Update 3 supporting disaggregated storage? I think the answer is just straight up no for this one. Not yet.
Just vSAN?
Yeah, well...
So
I don't know. Yeah, I guess it doesn't mention vSAN.
In the vSAN construct, we do provide a disaggregated storage method known as HCI mesh, and rather than being host based, it's sort of a cluster based construct. But that if that's what the person was referring to there, then yes, that's been introduced was introduced in vSAN 7, and of course some great updates since that time.
All right. Here's the one Ken is referring to, I think.
Yeah.
This will be
Well,
the first time we've done a non-English question, and I love it. Let's hear it, Ken.
Well, okay. So actually, Ulrich has just put a translation in there, but he's saying that he has 8 nodes in vSAN spread across 2 different rooms, and how can he architect this sufficiently so that it's best designed against room failure, basically.
Mm-hmm.
And I suspect the answer is witness and call it a stretch cluster and be done with it.
Yeah, if there's only 2 rooms, that's where you're going to have to sort of go with that stretch cluster arrangement with a kind of that third location for a witness. If you had multiple locations, let's say there were 4 different rooms that was in the same building, for example, you could do some explicit fault domains where you could have multiple hosts within each one. But then, of course, you have to have sufficient hosts in each room in order to kind of satisfy that request. So that's really would just be a stretch cluster arrangement.
All right. Let's see. What other questions? There was one about Oracle performance, and performance is hard to talk about. Here, let's see. Good choice for Oracle Data Guard that's syncing with physical database as well as same write throughput. It's a design thing, right?
Yeah.
Design it to get the right throughput you want. That's the nice thing about NVMe is it's so freaking fast that a lot of these problems have gone away. But then you've got with Data Guard, then you've got network stuff. If you're doing a physical database and using Data Guard across to the vSAN cluster, just make sure you don't have any bottlenecks there. vSphere supports a lot of interesting choices for really high bandwidth networking as well.
Network and storage, it's all about that. How much, how much do you want to invest in making sure that that's going to be able to satisfy the requirements?
All right, let's switch to vSphere. We're starting to get some vSphere things. There was a question about Rancher, other solutions like Cluster API, Rancher, and vSAN and vSphere. Let's get into vSphere, and we can talk about Tanzu, and we can talk about Babek wants to talk about the OS data layer and the SD cards, which we all knew was coming here. Questions about the changes of boot devices, and what we're doing about that. And let's get to that. I want to start with AI and ML, though. Justin has been so patient here, he cares about vSAN too. He's got a storage workload.
Definitely. Yes. I'm learning a lot from you guys. This is great.
This is terrific. Every one of these things I learn something myself. And so I'll suspend keep asking questions. We'll catch up with them in a minute here too. And that, but let's talk about the AI and ML improvements that are part of update 3 and last week's patch, what we're calling monthly patch 1, MP1, that sort of thing. What changed there?
So very quietly and seemingly innocuously, there was this dramatic change that happened in that monthly patch that, as you say, shipped out on the 21st of October, just a week ago. And a year ago, I was by hand adding GPUs into Kubernetes clusters and going through 15 steps to do so, hard manual process. Just as Pete related to in vSAN, we simplified it. We made it easier. And it's now a UI thing inside vSphere. When you've enabled workload management, enabling workload management is enabling Kubernetes effectively, and a system admin does that. And when they do that, something comes up called a supervisor cluster, which you can think of as supervising users clusters. The supervisor cluster is where the vSphere admin lives. And I'll go through the process in a second, but essentially now you have what you would have in the public cloud. You have a menu of GPU options or instances or VMs, a menu of them created by the system admin, stored in a library. And users can come along who never touch vCenter, who are not sysadmins. They're maybe Kubernetes people, or they're data scientists, AI ML people who care about, give me a Kubernetes cluster and I'm going to put pods in it that do AI ML. They care about the simplicity and speed with which you can get your Kubernetes cluster up. So those folks now have a library of instances created by the system admin that are different shapes and sizes of GPUs, different models, different shares, whole GPUs, partial GPUs, this library of things called VM classes. You can think of VM class like a template if you're a vSphere person, right? It's a bit like a template for creation of VMs. And so now the system admin has this extra duty to create that and supply that collection to the Kubernetes folks. And the Kubernetes folks say, I like to use a full GPU. I just want a full A100. Give me 40 gigabytes on that. There's this one instance in the library, a VM class in the library. I'm going to choose that. 5 minutes later, they have their Kubernetes cluster spun up in VMs.
That's really cool.
I looked at it and I thought, this is wonderful. This is wonderful. Makes my life so much easier.
Well, time to value is so much lower there. You don't have to mess around with all this stuff that there's no advantage to messing around with.
Secret passwords to get into this VM or that VM. Storing those passwords somewhere, logging into places I shouldn't be logging into.
Yeah, what was that?
Et cetera. And I went through all this, and it was painful. This is much, much easier. So
go ahead. I'm sorry.
The moral of the story is, Mr. Data Scientist, Miss Data Scientist, it's much easier now to create your Kubernetes cluster on demand, on the fly, 3 to 4 to 5 minutes with the GPUs that you need in your nodes.
Well, that's the amazing thing with all of this too. They just simply go in and define their YAML for their cluster like they would always do. And they just define a particular VM class that says GPU. And those worker nodes are now good. Nothing really changes from that perspective, from the data scientist perspective. They just say, my cluster GPU enabled, please.
That's
so the
right.
vSphere admin doesn't need to know anything about really what they're doing with that code and what they're doing within their own private TKG clusters. They can simply say, I'm going to define this as a resource that you can then draw upon as a data scientist yourself. And the vSphere admin's job is done. It's just simply extending concepts they're already familiar with. So it's nice that nobody needs specialist level knowledge on either side of these things. I think that's really, really powerful.
And the best practice that I'm discovering is name those VM classes with meaningful names like A100 40 gig or A40 20 gig, so that everybody will recognize what that VM class does. You don't even have to advertise it. It's there.
Naming is so hard. Well, and you pick a name and you don't realize that you can't change it in the future without trouble, or native key provider, we've been dealing with that a little bit too. That's the hardest thing about enabling it, is figuring out what to name the key provider. But anyhow, I digress. You had mentioned to me at one point too that the VM class isn't necessarily it's a Kubernetes thing, sort of, but it's not an AI ML thing. It's not a Kubernetes thing. That there's other things you can do with it. Is that right?
That's right. VM class has been around for a couple of iterations of U2 and U3 in vSphere. And originally, it was there to make the master program that everybody uses in Kubernetes is called kubectl or kubectl. And once you have access to your vSphere space, your namespace, and you have kubectl, you've downloaded it from somewhere, from the supervisor cluster, you can go ahead and create VMs this way. You don't have to create nodes in the Kubernetes cluster. You can actually manipulate VMs, bring them to life, fire them up, tear them down. Things you would normally have done through vCenter only, you now do through kubectl or kubectl, which is very unusual. Very unusual. It's almost a new vCenter, and
that's exactly what I was going to say. It sounds like a whole new front door to vCenter here.
Right. And why would you do this? Well, you're not creating a Kubernetes node. You're not talking about Kubernetes clusters, and yet you're using kubectl to manage these things called VMs. This, by the way, is unique to VMware. Well, you would do that for exactly the reasons Ken was mentioning earlier, which is I've got a database. It's not containers. It's not Kubernetes aware. It has nothing to do with Kubernetes, but I want to manipulate it anyway in the same way that I'm managing everything else. And I'm managing Kubernetes for my application pods. I can manage databases in my VMs separately.
What if you just wanted to mix and match too?
Exactly.
The ability to mix and match is a real strength in with vSphere with Tanzu, if you ask me. And you didn't, but I think that's a really important thing, and so that's really cool. So what else? AI and ML and that. What else do we have going on with AI and ML and update 3 and some of the
a lot.
recent releases?
Sorry.
No, go ahead.
I think of it as 3 themes. There's that rapid creation of Kubernetes clusters with GPUs now, and that's GPUs are essential to machine learning people. They have to have them. The second theme is Nvidia AI Enterprise, which is our joint work with Nvidia, which has been going on for a year now and is showing fruit in a big way. Nvidia is shipping Nvidia AI Enterprise now on VMware exclusively, on vSphere exclusively, and is integrating with all that work that I just described to do the VM class and testing. Testing on top of that. And that will be a release of NVIDIA AI Enterprise very, very shortly, within months.
Well,
so that's one.
One brief bit of color on that as well. I think a lot of people think that when you're using GPUs that you just need, historically the way they've seen it is, I'll attach a vGPU to my VM and we're done.
Correct.
But the NVIDIA AI Enterprise is a suite. It's a huge framework that you have at your disposal with a full set of tools and frameworks and
really meant to speed the whole thing along, right?
Absolutely right. You get a small taste of the NVIDIA GPU cloud when you get NVIDIA AI Enterprise. You get 6 or 7 tools there that are friendly to the data scientist. They're kind of strange tools for a VMware person to look at. They have names like Rapids, TensorRT, Triton Inference Server, but they're all very relevant to a data scientist's world because they're frameworks that data scientist will use every day. Rapids is for columnar data, for example, data that came out of a database. TensorRT is for taking your machine learning model and optimizing it, reducing the word size to make it more memory compact, more speedy. And Triton Inference Server is, okay, I did all this training work. Where do I put this thing that I've trained? Where do I serve it up to?
vSAN, clearly, duh.
You put it on vSAN, and all of my clusters. I've created half a dozen of these Tanzu Kubernetes grid clusters over the last couple of weeks. They're all running against vSAN. They all run fine. That's the tie-up between us, and the persistent volumes are extremely important too.
And that's one of the beauties, again, this framework, everything that goes into NVIDIA AI Enterprise. Again, the data scientists don't need to change it. They don't just say, I can no longer use those tools because I'm putting it on vSphere and that's running on vSAN. It's totally opaque.
They're right here for you, pal.
Runs. Yeah.
Boom.
They need not see it at all. They need not see vCenter at all.
Yeah.
Yeah, I think about what it must be like for that IT decision maker, the architect, the administrator now, what they can offer up to their consumers and their organization is just unbelievable. For what it was even 5 years ago, and for you to think about that you could harness the capabilities of GPUs, be able to serve up the ability to spawn either monolithic applications or next generation applications through these other vehicles. It really is extraordinary.
It is. It's very impressive. My congratulations to the Tanzu team. This is good stuff. And the whole idea is to be cloud-like, to make it as easy as you would have experienced in a public cloud to get your GPU up and running, quickly in a Kubernetes cluster. It's a non-trivial task. There's a lot of things going on under the covers. You watch the recent tasks pane in vCenter when you do this, and 30 or 40 items go past you very, very quickly. It's a big deal. But the third leg of the stool is performance. And my good friends in performance engineering at VMware published this wonderful study. There's a rising benchmark in the machine learning world called ML performance. It's a suite of benchmarks. They came in at somewhere between 95% and 100% of native performance, as they've been doing for years. These guys have been working on machine learning and GPUs for, as far as I know, 5 or more years. Some of them even invented some GPUs themselves. And they're full-time on this, working with NVIDIA on proving out the performance of this. It's in the low single digits as far as If there's any overhead is concerned, it's low single digits. So that's one of the main worries about people doing machine learning on VMware is, am I going to lose performance? The answer is no.
I
Yeah,
imagine
there
a
was
lot
also
of. Sorry,
go ahead.
Go ahead.
Well, I was just going to say that there was also a study recently about performance. You reminded me of here that where we did a performance study, us versus some of the other solutions out there. The fact that we can run 6.3 times the containers in the same amount of hardware on vSphere. ESXi is so efficient that it can do that.
Right.
Is also something I wanted to mention. Not to brag, but yeah, to brag a little bit. That's big news. That's serious business.
Yes, people are very concerned about performance in machine learning because they've been used to having an entire machine to themselves, entire GPU to themselves, and we're not taking that away. You can get that on vSphere. You can get the entire GPU to yourself, or 2 GPUs, or 4 GPUs to yourself in your own VM if you want to. And this new VM class capability can do that.
That's really cool.
And I imagine that the lack of performance degradation is very similar to why there's no degradation on containers. It's the memory handling is just so efficient at swapping between VMs, perhaps in worker nodes, whatever it happens to be. I imagine that that's probably why. I mean, I obviously haven't written the paper, so I don't know, but I'm guessing at that. But I mean, that's concomitant with what we've seen on the vSphere side with containers. So
you're exactly right. You heard me mention memory in the GPU context. It's called frame buffer memory on the GPU, just a term. All of the data that's being treated in machine learning training is going into that frame buffer memory and offloaded from main memory, offloaded from the CPU. So the CPU is hanging around, and that was the point of that paper. If you've got a large system with a large number of cores, this machine learning workload might only take up a corner of that CPU bandwidth. It may not take it up at all. You're left with some space to do other things on that same host.
I can't wait to see where we go with this with Project Monterey. And on first glance, that might not seem directly relevant if you're not familiar with it, but Monterey is really about using DPUs or smart NICs, as you might know them, for various different offloads and various different functions. And that was one of the most popular sessions at VMworld this year as well, was around 10 things to know about Monterey. And the reason I'm saying that is when you look at what we can offload using a DPU, we can take network stacks and offload that. We can take processing of firewalling and offload that. We can do all sorts of different things, all of which has the function of freeing up more CPU cycles and freeing up more resources so that the VMs get access without interrupts and all the rest of that. So we get higher densities with less contention for those resources because we're offloading things onto DPUs. So then if we got things on GPUs running dedicated, we got high density containers and very low interference for memory resources. The future's looking pretty cool around this aggregation of technologies.
That brings up another interesting point, Ken, and I agree with you. The DPUs are going to be very exciting. In the machine learning world, the really sophisticated folks are doing distributed machine learning. They're distributing it in the same way with the stretch clusters at the vSAN level. This is now taking the same workload and running it against 2 or more servers that are networked together. Mm-hmm. And machine learning is very chatty. It likes to swap data between one GPU on one side of the network and another. There's a lot of data in transit, as Pete described when he described the encryption. And DPUs and network cards are going to be highly important for handling that GPU to GPU communication in an encrypted fashion, as you'd explained to us, Bob, because this data is sensitive. It could be transaction data. It could be PII data. It's data that refers to historical transactions in the company. We have a small hint of that in the VM class mechanism that we saw from last week, which is the ability to put a GPU into a VM and a network card or a virtual function representing a network card into the same VM. So that GPU and that network card are aware of each other. They know where each other is so that they can shorten the path between them when that data exchange goes on. That's there in the VM class now.
Hey, you guys, I want to get to some of these questions. There's some folks being very patient out here, and I appreciate it. Thank you for all the questions out in the chat. We are here to answer questions as well as talk about all this stuff. This is very interesting stuff. And we didn't even mention PyTorch, which is my favorite tool set because I like burning things. But I think different perhaps. Babak has got a question about the changes with SD cards in boot volumes in update 3. And I'd like to talk about that just briefly. We've got some materials about it. One of the things about SD cards, these things, all the flash memory and flash storage and NVMe stuff, all that stuff. In fact, I've got another one right here that I've been using a lot to illustrate this. These are smart. They people don't realize it, but flash memory, you destroy it a little bit every time you write to it, and it's a consumable consumable thing. It's a consumable part, and so eventually it wears out. You write to the same spot every time, and you kind of wear through it. It's kind of like a hole in your shoe. You walk on the same part of your shoe all the time, you'll wear a hole eventually through the sole of your shoe. And don't mind my facial expressions here. And so we've got, these devices deal with it intelligently. This is a 480 gig drive. It's actually got 525 gigs of storage in it. And so it does something called wear leveling. It moves all those writes around to try to spread the writes out. You see these measured drive writes per day. You'll see it gives you an indication of how much you can write to them and how fast, how long they're gonna last until they wear out. These things are super dumb. They don't have that sort of intelligence. You can write to the same spot on them over and over and over again, and they wear out. And so people have been learning over a long course of time here that SD cards need to be mirrored, that operating systems, when you install them on SD cards, they kind of wear them out. And so we just finally kind of got opinionated about it. vSphere 7 changed the on-disk format of the boot volume. And in reformatting it, we run into bad sectors all the time. And then it looks like, oh my goodness, vSphere 7 killed my host. Well, no, your host was in the process of dying anyhow, and we just happened to run across it, And so we've got some new resources about this. Here, I'll share it in my thing here, given that my video is glitching anyhow. A coworker of ours, Jatin Purhit, put this together. There's all sorts of information here about this problem, what to do about it, how to move that OS data layer, all that sort of stuff. And so hopefully this helps a bit. I'll leave it up for a second.
And look, at the end of the day, the program erase cycle is destructive even with wear leveling. And wear leveling gives you a longer lifespan of the medium, but it doesn't fix the problem overall. So you get better durability out of things that have wear leveling built in.
Yeah, Flash is durable, but it's got a lifespan too, and so so.
And I think the biggest fear that I have with these things is that corruption can be silent, so you don't necessarily get a lot of warnings. And if this is your boot device, and Jatin is on our chat on YouTube as well. So
excellent.
The fellow who wrote that guidance for you is here. So ask him the questions. But what I was going to say on that is that it's more dangerous than it might even appear. And people who are a little upset that we made changes, I get it. It requires you to change the way your environment is architected, but it really is longer term,
short-term pain for long-term gain. Like it's just you rip the Band-Aid off, and it sucks. And there's a path, now it's called degraded mode. It'll warn you about stuff. You can move your scratch volumes. There's stuff you can do. And so Jatin's got that all documented. Here, let's see. That's some other questions. Side question about VTA. Is there a way to change the host attestation default time? Well, yes, there is. I have no idea what it is specifically, but the engineer that wrote it told me that there is, and we can find it. If you want to email me, I'm rplankers@vmware.com, and why don't you email me, and we'll get a wonderful fellow by the name of Jesse. We'll ask him, and he'll be able to tell us. I'm pretty sure that exists. But I don't remember. I don't know everything. I know that's hard to believe, but I don't know everything right offhand. Let's see. Does vSAN 7.3 support NVMe over fabrics? No, vSAN 7 Update 3 does not, but vSphere 7 Update 3 does. That's a huge improvement here. So NVMe over fabrics, NVMe TCP, are those terms are being used interchangeably. One is the I don't know. Yeah, the answer to your question is yes. So
vSphere, yes, vSAN.
yeah,
Yeah.
vSphere does its own thing, or vSAN does its own thing, and they're cool. Let's see. Do you mean that ESXi running on hosts can communicate with a VM running on ESXi running on a DPU if we install the ARM version of ESXi on DPU?
No, that is not what I said. No.
That's a lot of layers of inception there.
Yeah.
ESX on ARM is definitely the worst kept secret ever. And it is what would power some of these DPUs, but I don't think there's VMs running directly on the DPUs.
Look, we have a couple of projects underway. ESXi on ARM is one project. ESXi on DPU, which is de facto ARM as well, is a separate thing. So go check out Project Monterey, Monterey, at VMworld. We have additional information, but this stuff is not production code yet. So we're not making any promises about what can or can't take place with that.
But the early forerunner of that, the ConnectX-6 high-speed networking from Mellanox and Nvidia is running today on vSphere.
Oh, yeah. Very cool. Cool. Let's do one more question. It only looks like there was a question about Rancher and cluster APIs. I don't know that much about Rancher. I think Rancher actually technically might be a competitor of Tanzu, but I suspect that if it one of the nice things about Tanzu is that it looks like a normal Kubernetes cluster. That's a really intentional thing that we do with vSphere with Tanzu, is that, and across all of that stuff, wherever Tanzu is running, it looks like a normal Kubernetes instance, because we want people to be able to use whatever tools they want. I mean, we've got an opinion about our own tools that they're great and everyone should use them, clearly. But, if you've got other things, not everything is everything to everyone. If you want to use Rancher, you should just be able to use it as a normal Kubernetes instance. That sort of thing. So.
Yeah, you can run vanilla Kubernetes yourself, construct it yourself on VMs if you want to. It's a fair bit of trouble to do it, but you can do that. Kubernetes is not the easiest thing to get set up and running, and we do that for you. Is one of the value.
Yeah, that's
Rancher is another instance.
So easy.
Rancher is another instance of that. You could do all the work yourself and get it running. Yes.
Yeah,
I mean one of the things with Tanzu is that we have that supervisor cluster that allows you to use workload domains. It allows you to use, VCF. It gives you storage classes. It gives you the ability to do all sorts of really interesting things in terms of controlling that higher level functionality of carving up your clusters and so forth. So there are advantages to using Tanzu. That doesn't mean that you can't carve your own using whatever distributions you want. You just lose some of those advantages, but you get the same experience.
Do whatever you want. It's infrastructure, All right, last question here that I see out here. In fact, how to migrate from pre-vSAN update 3 to the newer vSAN update 3 for both standard vSAN and stretched vSAN clusters. Any recommendations? Pete, do we have any thoughts on this?
Yeah, absolutely. So first, go out to the operations guide, the vSAN operations guide. We focus heavily on workflows that are going to help you with upgrading your vSAN clusters. But inherently, it's all the same, whether it is a standard vSAN cluster or a stretch vSAN cluster. You're just going to run through the process of allowing the lifecycle manager to update the host after you have upgraded vCenter server. That's always a good reminder.
Yeah, vCenter server first, please.
Yes,
always.
And then of course following all of the the pre-checks and stuff that we now build in to the product. Now it's going to depend a little bit on what version that they are coming from. Obviously, if we're talking about an extremely old version of vSAN, there will be some nuances there. But for the most part, I would follow what we have, out in the operations guidance.
Cool. I lied. I'm full of lies today. My 6-year-old actually told me I'm a liar last night, so I'm just living it out today. But this looks like a kid here as well. AJ, I'm sorry I missed your question earlier. Currently running 6.7. Can I upgrade straight to version 7 update 3? Or should I go to 7 and upgrade from there? No, don't go to 7 GA. Skip that whole mess. Go straight to version 7 update 3. Version 7 update 3 is the best version of vSphere ever. minus somebody had mentioned we have some bugs. Yes, HA has got a bug, and there's an unmapped thing about it too going on. We're working on those. We're sorry about those. If those are biting you, please open a support case when you run into stuff like that. And our global support services folks are excellent, and they will help you figure it out. And I know they've got engineering and all that stuff engaged right now about bugs. HA, like I said, unmap as well. The unmap one is causing purple screens of death, which is not cool. If you run into that, open a support case and we'll get you straightened out. And we're sorry about that. But
Hey,
yeah,
Bob.
definitely go straight to the latest version of whatever major version you're updating to.
And while we're talking about that, how many days left in support for 6.5?
6.5 and 6.7 have less than a year, 350 days left or something like that.
That sounds about right.
And
Yeah.
so if you're not thinking about that, about upgrading, I would start, like you can do vCenter server and then work on your hosts. It doesn't have to be all one giant operation. People like to think of these things as like, we got to do it all at once. And, sometimes there's reasons to do that, but, break it up, do a little bit here and a little bit there. And by the time it goes out of support, you won't have to worry about it anymore.
353 days, if I am reading.
All right, there you go.
Says, yes, October 15th. So I think that's about
what will be the
353
disk.
days.
Oh, here we got other questions. Okay, yeah, October 15th, 2022 for all vSphere 6.x. If you're still running 6, I would get off of that soon. Like I would have gotten off of that a while ago, but everyone's got their things. Let's see, disk format for vSAN. I'm assuming that disk format is 15 for 7 Update 3. Let's see. And Jatin, you're being asked for some Power CLI guide documentation. Power CLI, go to developer.vmware.com. Got a lot of really interesting stuff. Power CLI 12.4 really, really got some cool stuff in it. Really interesting stuff, and a lot of good things there. A lot of new API calls, the ability to call all of the vSphere APIs. That's huge. vSAN, the Power CLI 12.4 has got a way of interacting with vSAN that looks like you're just traversing the whole vSAN data store itself and copying things in and out of it, and it's crazy and it's awesome, and you should use it. I'm redoing a lot of the security configuration guide for vSphere with all of the new API calls and that. In fact, that's what's taking me the longest, is looking them up. I'm not the best programmer in the world, so everyone's going to have to put up with my terrible coding. But but as an example, like switching it to the new Power CLI bindings has been really straightforward. So, how is the future going to be for virtualization? This is the greatest end question ever. Pete, how's the future going to be for virtualization?
Well, they are indelibly tied together in so many ways. I mean, there's just no way to separate the two. So I think the very fact that we have this more efficient way to create and move workloads, no matter how they were built, how they were architected, and how they're operating, it means that virtualization is just going to be a key aspect of that. And it's who can provide that platform that's going to be able to provide the most agility. So whether it's, those on-premises environments or in the cloud or a hybrid of both.
Justin, what do you think about the future for virtualization? A fad or not?
No, I think it's very bright future for virtualization. I'm involved in AI and ML, and you can't get more futuristic than that. It's rapid. It's under rapid adoption. 25% of enterprises have deployed it. That leaves 75% more to go. So we're heavily into these new workloads. We believe these new workloads will work fine on VMware. The debate about containers versus VMs, I think, is over. Containers and VMs go together. They just go together. Containers don't
Google
separate.
said that the other day, didn't
They
they?
don't-
Finally
Yeah,
acknowledged
containers
that
don't
VMs are
separate.
cool.
Yeah, exactly. That's becoming more and more. Every container that you're running on a public cloud is in a VM anyway. So run the same thing on premises. So I think it's a very exciting future with all this offload on DPUs and offload to GPUs. There's some really exciting things coming for virtualization. I'm very optimistic for it.
Ken, future virtualization, plus,
Yeah.
minus?
Well, I remember somebody back in the 90s telling me that computers were probably a fad and this internet thing was probably just going to go away. And yeah,
Well, it might lead to the end of civilization if that's what they're thinking. But
global EMPs that are some alien species rains down upon us. Maybe, yeah. Then it's a fad. It's going away. I think the key to that question is virtualization. What are you virtualizing? And the answer is we're virtualizing more than ever before. If you look at the transition into hybrid clouds and SDDCs and where things were going a couple of years ago, more and more things are being pulled into that virtualization layer around storage, around networking, around even management and security. And it's not just VMs. So virtualization includes all of these other pieces that help deliver, whether it's a hybrid cloud, an on-prem, whether you're running in a public cloud, whatever it happens to be. Virtualization is required in order for that to work. I think at the end of the day, people shouldn't care where their applications run. If you want to deploy an app, do you care if it's in a container or in a VM? Today, you kind of do. Do you care if it has a GPU attached to it or not? Yeah, today you have to think about these things as you're deploying them. I think what's going to happen in the future is that all of this stuff gets made easier, and that's predicated on this layer of virtualization that enables you to say, I'm going to deploy my application, and I don't care where it runs, and it's going to self-describe. I mean, look at YAML. I mean, that's the way things work already in that container space. It's a self-describing application set. Now, when we converge what goes on with traditional applications with emerging application types, whether they're running in containers, whether they have GPUs, whether they're orchestrated with Tanzu or Kubernetes, that shouldn't matter. Application developers and IT owners should be able to just simply deploy and let their apps run anywhere they want. But virtualization is required in order for that to be the case. Even in a modern apps containerized world, you still need that layer in order to say that you don't care where the application runs. So I think the future is going to be applications running where they make the most sense to run, and that's predicated on a virtualization layer in order to get there. So I think it's here to stay, just a guess. But
yeah, not a fad. So yeah, no, I agree with you. And I like that we're resolving the container versus VM debate. That was a debate there for a minute or two. And, all of it. We never get rid of anything in IT. We only just add things. And so figuring out our biggest challenge is going to be figuring out how to make it easy for people to do their thing. And I think that's really a strength of what VMware is working on. Being able to float between clouds and on-premises stuff, and wherever you want to run this stuff, you can do it. And so I think that's going to be a powerful thing. So my video is freaking out. I think we've come to the end. We're 12 minutes over. There's a couple of questions out there yet. Compute policy. The new compute policy thing is a work in progress in vSphere 7 update 3. It's mostly there to help with the VCLS improvements, and that vSAN global deduplication option. That's a whole conversation that we'll probably have to get into at another time. And vSAN U3 coming to the VMware Cloud Foundation bill of materials. That when there's a new version of Cloud Foundation, you'll be able to upgrade to that has update 3 in it. You'll be able to update to 7 update 3 and disk format 15 as well. So with that, I thank you very much. I hope you're all staying safe and sound and are doing all right. Thanks for tuning in. We really appreciate you. If you can like this thing, I could be a YouTube star. Ring the bell, subscribe, like us wherever you're at. Hey, somebody just liked us. Thank you. And I appreciate it. It helps with our ratings here. And so thank you all. Take care. Okay.
Thank you.